Right, guys, so welcome back. Welcome back to another series, guys. Now we're going to look at a new type of topic, measure, which is really tied in with the geometry, but I thought we'd split it up to avoid confusion between the two. So, yeah, as always, guys, we really hope to learn a lot of skills here. And remember, guys, this is one of the, I think, big four topics that normally comes up in the math section. So it's a really good topic if you're going to start practicing for the BMAT to start here. So let's start, guys, with the first question which came up regarding the measure topic, which was BMAT 2019 question 16. So it says one side of a rectangle is 7 minus root 5, and it says the area is 66, and it says what's the perimeter in centimeters of the rectangle. So guys, pause the video, give yourself a minute, be sure to be back after that minute, and then we'll be going through the solution. Okay, guys, so welcome back. So let's go through this. So what we have here then is a rectangle. So something like that, and we know that one of the sides is 7 minus root 5. So I'm just gonna, obviously we don't know if that's the bigger side or the short side, but for argument's sake, let's just assume it's the bigger side, 7 minus root 5, and the area is 66 centimeters squared, right? So obviously the area, so if I call this length x, so the area of a rectangle is just the two lengths times together, isn't it? That means that 7 minus root 5 times x should be the 66. Therefore, x is going to be 66 over 7 minus root 5, isn't it? So we have that so far. Also, guys, one thing that it says in the specification for the BMAT, so one thing we don't like in fractions is having surds in the denominator. And the way we get rid of surds in the denominator is we do something called rationalization. So in this type of rationalization, what you do is you times the top and bottom by the conjugate of the bottom. So 7 minus root 5, the conjugate of that will be 7 plus root 5, and then over 7 plus root 5. So then that basically, guys, is going to be 66, 7 plus root 5, over, and then if you times the bottom denominator, you get 7 times 7, which is 49, and then you get plus 7 root 5, minus 7 root 5, as it cancels, and then minus 5, basically. So therefore you get 66, 7 plus root 5, over, what's that going to be, 44? Yeah, 44. And then what you can do, guys, is divide top and bottom by 22, isn't it? So then if you divide top and bottom by 22, you're going to get 3, 7 plus root 5 over 2. Right, so that's going to be the other length. And then obviously to find the perimeter, you're just going to do 2 lots of 7 minus root 5, which is going to be 14 minus 2 root 5, and you're going to do 2 lots of 3 lots of 7 plus root 5 over 2, right? So then that 2 and that 2 just cancels out. So you're just left with 3 lots of 7 plus root 5. And then if you expand this out, you're going to be left with 21 plus 3 root 5. And then if you just merge that with that, what you're going to get is 35 plus root 5, I think. 35 plus root 5. Yeah, that should be right. So then therefore, guys, the answer you're going to get then is D, which is this one over here. So hopefully, guys, that has made a lot of sense. And as always, we look forward to seeing you in the next video. Okay, guys, so previously we looked at this question, BMAT 2019, really just talking about areas, perimeters, and it also brought in a novel topic from the number section, actually, which is rationalization. I think that was the main key skill that this question was trying to test. So this is what I mean, guys, with the BMAT Maths, very rarely you just get one topic in isolation. It will be a mix and match of different topics, such as what we saw in this question. Without further ado, let's go on to the next question, BMAT 2018 question 12. It says all 4 corners of a rectangle are on the circumference of a circle. The rectangle has a perimeter of 24. The ratio of length to width of the rectangle is 3:1. It says what's the area of the shaded region in centimeters squared? So guys, pause the video, give yourself a minute. Be sure to be back after that, where we're going to go over the solution. Okay, guys, so welcome back. So in this question, we know the ratio of the length to width of the rectangle is 3:1. But let's just say, for example, the length is 3. The lengths are 3 and 1. Then the area should be 2 lots of 3, because you have 2 big sides and 2 small sides in a rectangle. So 2 lots of 3 is going to be 6. 2 lots of 1 is going to be 2. So 6 plus 2 is going to be 8. So that's not going to work. So if we double up these lengths, we're going to get 6 to 2 And if you have a 62, you're going to get 12 plus 4, which is 16. So still not working. So if you triple the lengths, then you're going to get 9 and 3. And then you're going to get 18 plus 6, which is 24. Yeah. So that means that the length must be then 9, 9, 3, 3. So hopefully that has made sense, guys. Then obviously to work out the, it says, what does it say? The area of the shaded region. So the area of the shaded region is going to be the area of the circle minus the area of the rectangle. So the area of the rectangle is just 9 times 3, which is 27. Now the area of the circle. So to find the area of the circle, we actually have to first use Pythagoras' theorem to work out this length here. And that's going to be a right angle. So if we use Pythagoras' theorem, it's going to be square root of 3 squared plus 9 squared, which is going to be the square root then of 9 plus 81, which is the square root of 90, isn't it? Now that's just root 9 root 10, which is 3 root 10, right? So that's going to be that line, dashed line over there then is the diameter. So the radius therefore is going to be 3 over 2 root 10. Therefore the area of the circle is going to be pi r squared, isn't it? So 3 over 2 root 10 squared. So that's going to be pi 9 over 4 lots of 10, basically. So that's going to be 90 over 4 pi, which is 45 over 2 pi. And then we just have to minus it from the area of the rectangle. So it's going to be 45 over 2 pi minus the 27 we have here. So that's going to be then, hope you can appreciate, guys, going to be f. So hopefully, guys, that question has made a lot of sense. And as always, really look forward to seeing you in the next video. Alright, guys, so welcome to the next video. Previously, we were looking at BMAT 2018 question 12. This question really testing our ideas of if we can work with compound shapes and work the areas of compound shapes using those ideas. But now, guys, we're going to move on to the next question, which is BMAT 27, question 24. This is a diagram, so the shape made from a quarter circle radius 6 and a right angle triangle with hypotenuse of length 9. So which of the following expression gives the areas in centimeters of the shape? So guys, pause the video, give yourself a minute, be sure to be back after that. We're then going to be going through the solution. Okay, guys, so this is another compound shape question. So to work out the area of that shape, what we're going to really do then is the area of the quarter circle plus the area of the right angle triangle. So I'll just call this AC and AT. So AC would just be pi r squared. There's going to be pi times 6 squared, but it's only a quarter of the circle, so you have to divide this by 4. So the 6 squared is going to be 36. Divide that by 4 is going to be 9. So you're just going to get 9 pi there. Then the area of the triangle, right? We have to do a bit of work here actually, because we need to find what this length is. Because then we do that length times 6 divided by 2, so it's going to be the area of the triangle. So we basically need to do Pythagoras to find that. So that length then, if I just call this then x is just going to be the square root of the hypotenuse squared minus the other length squared. So you see, guys, how this is minus not plus, because when you're finding the biggest length, which is the hypotenuse, you use plus with the Pythagoras theorem. Whereas when you're not, when you're finding the other length, you do the hypotenuse squared minus the other length squared, square rooted. So here we're going to have square root then of 81 minus 36. So that's going to be 75, 45, I think. So square root of 45, which is going to be root 9 root 5, which is going to be 3 root 5. That's going to be that length. So therefore, the area therefore is going to be 3 root 5 times that by the 6 divided by the 2. And that's going to be 18 root 5 divided by 2, which is going to be 9 root 5. So the total length therefore is going to be 9 pi plus 9 root 5, which is going to be C. So hopefully, guys, that was of some use to you and you've learned some skills there. But as always, guys, we look forward to seeing you in the next video. Okay, guys, so previously you looked at BMAT 2017, question 24. Again, compound shapes. Remember, in this measure topic, guys, compound shape is quite a common topic that comes up. So if you're not so strong in this topic, highly advise that you cover that. Now, guys, we're going to move on to BMAT 2016, question 12. So this question says the diagram represents the circular cross-section of an artery with external diameter D of 1.6 centimeters. The thickness of the artery is 1 millimeters. What's the internal cross-sectional area of the artery, which is the shaded part of the diagram? So guys, pause the video, give yourself a minute, be sure to be back after that, where we're then going to go through the solution. Okay guys, welcome back. So let's go through this. So we need to work out that area. So that's basically a circle, so we need to work out the radius, isn't it? So to work out the radius, which is this area, right? What we can do is split that 1.6 into 2, so you get 1.8 centimeters. And obviously this part we have hidden here, that's 1 millimeter, right? Which is basically equivalent to 0.1 centimeters. Because remember, millimeters to centimeters is a factor of 10. Therefore, that R, if I call this R is going to be 0.8 minus 0.1, which is 0.7 centimeters. So basically what we're going to do, and actually guys, since the answers, just look at the answers, they're in millimeters, so I'm actually going to convert that to millimeters. So that's going to be a factor of 10 again, but we're going to the smaller units after times. So times 10 is going to be 7 millimeters. So we're just going to do then pi r squared, pi 7 squared, which is 49 pi. And then the answer therefore, guys, is going to be D. So hopefully, guys, that was pretty straightforward compared to some of the other questions. And as always, guys, we look forward to seeing you in the next question.